Alright guys, welcome to the first lesson of CP, College Prep Algebra 2. In Unit 1, we're going to do a review of Algebra 1 topics. We can't move on to new stuff if you're not mastering the old stuff. So, as you can see, it is, we got a few lessons here, 5 lessons, and that will be followed up by a review and a test. So we're going to lesson 1 here. It's just a little bit of a warm-up on solving equations. So our goal today is going to be solving linear equations, meaning they would form lines if we were to graph them, and rewriting formulas, meaning, well, you'll see that later. All right, let's hit up the warm-up. All right, if I don't, I may have to cut off this video, and it might be in 2 parts. This is I know it's only the first lesson. This one's a rare one that's a little bit longer. Anyway, solve the following equation. So I have to get x by itself. So what's the first thing I would do here? Would I get rid of the 2 or get rid of the 4? Well, to give you a hint, a refresher, that you get rid of last. Anytime you have a coefficient with the x, that's what you get rid of last. So we need to get rid of the 4. We want to subtract 4 from both sides. Now when I say that, we just cancel on the one side of the equal sign, and then we cancel on the left, and then do the math on the other side. And then 2 times what is 4? Well, that's obviously 2. If you're going formal, if you're going the formal way of doing it, you would technically say, I need to divide both sides by 2. Number 2, what would I get rid of first? This minus 5, so add 5. I go a little faster in my videos than I would in real life because you guys can pause and rewind if you missed something, especially when you're doing the ed puzzles and answering questions on there. Feel free to pause, rewind, rewatch, whatever helps you. So that would be careful here, 0. And then you would, let's go technical with it, and divide both sides by -3, and you would have 0. What would you do first here? You want to distribute here. Distribute to get rid of parentheses. Remember, that would, nope, I didn't distribute correctly here while I was talking. Remember your 3 times x, and then 3 times -2. All right, stylus is acting up. So what would you do next? You would add 6 to both sides. So you'll bring down 3x and equals 15. Remember to always be on high alert of where your equal sign is. You know, there's a left side and a right side. So notice that when I'm adding, when I say add 6 to both sides, that means once on the left and once on the right. And then you would say, I'm going to divide both sides by 3, so you got x is 5. And then number 4, we have a variable, or a variables on both sides problem. Normally, remember your steps are always get rid of parentheses first, which we don't have here. Then after that, you would combine like terms, but we don't have any of that applying here. So we have variables on both sides. We're going to move to one side. So let's move this 5x term to the left. We're going to subtract 5x from both sides. So it'll cancel on the one side of the equal sign, and then do the math on the other. That'll be 1x. And then it's pretty obvious you would add 10 to both sides. So x is 22. Okay, order of operations, also known as Pemdas. The P stands for we're going to be, oh, let me back up here. What we're going to do next is we're going to go into a little part where we're not solving any equations, we're just evaluating expressions. So we're going to use the order of operations to simplify things down to one number. All right, so order of operations we commonly refer to as Pemdas. The P is always first. That means parentheses or other grouping symbols. That means that we get anything that's within a grouping symbol, we have to get it down to one number. And then after that would come exponents. Then after that would be multiplication or division. They're in the same family from left to right. And then lastly, adding or subtracting, going from left to right. So in the first example here, we need to, it's giving us an expression. That's this right here. It's math without a whole bunch of math symbols and numbers without an equal sign. And after that, it's telling us when A is -5 and B is 3. So what we want to do when it says evaluate, that means plug in the numbers for, replace the letters with numbers, and then we're going to use the order of operations. So let's do that now. So this would be 4 times A plus 7 times B plus 3 times A minus 2 times B plus 2 times A. So we don't have parentheses here. We don't have exponents either. So we're going to be doing multiplication from left to right. So we're going to do this first. That'll be -20. I'm going to be there are shortcuts here, but I'm going to be really formal today since it's our first lesson. That's supposed to be a 5 at the end. My stylus is acting up. And then keep going, multiplication left to right. So plus 21. Then we have more multiplication right here. That'll be -15. We'll call it -15. Remember, negative numbers are the same thing as minus. And more multiplication. God, I hate this problem. Alright, first problem of the year is extremely long. So that'll multiply to get -6. And then multiply again. That'll be -10. And then you can add or subtract left to right. So -20 plus 21 is 1, -15 is -14, -6 is -20, -10 is -30. All right, letter B. Let's plug in the 4 for A. We got to work on parentheses first, getting each set of parentheses down to one number. So we'll work on those simultaneously. So within the parentheses, we can do 2 times 4 to get 8. And also we can work on the other set of parentheses in the same step to save some space. The first one we still got to work on though, get it down to one number here. Let's add those. So now it's 3 times 13 plus 2 times -1. So we'll do multiply next to get 39. Then multiply here to get -2. And then subtract 37. All right, letter C, very tricky here. We have an exponent thrown in. And when we're subbing negatives into exponents, we got to be careful and we got to use parentheses. So let's go ahead and plug in now. Now be careful here. You have a negative in front of this x. So what this means is put the negative down, then open the parentheses for x, throw in your -3, and then put your exponent carefully outside of the parentheses. And then from there, what do we do next? Well, we don't say parentheses here because each parentheses only has one number in it. So we actually go to exponents here. We have to stay strict. We have to do that squared. Now, what is going to be squared is this -3. So the negative that's out in the front of the problem gets dragged down. Then we do what I highlighted. We do -3 squared, which is 9. So we drag down a 9, and the negative that we drag down in front, it becomes -9. So we have to be really close, really careful when we're doing this. And then we would multiply. So that'll be +27, so put a plus. And then we can add or subtract left to right because that's all that's left. -9 plus 27 is 18. 18 plus 8, 26. Next, you do number 1. I want you to pause this video and try to do it on your own and see how it goes. You could do it on a piece of paper next to you or your notebook if you printed it out. Okay, so let's plug in for x and y. So that 3xy is 3 times x times y. Sometimes I use parentheses for the multiplication. Sometimes I use the dots. I tend to go back and forth. Then be careful with the minus x squared. So bring down the minus. Then -2 in parentheses, then squared outside. Plus 2 times y. All right, so what to do first? No parentheses here. They're all down to single numbers. So what do? Exponents, Pemdas, P then E. So we are going to do -2 squared. So that'll be 4. Then bring down everything else with it, around it. All right, then we're going to multiply. This will be -6. Then -6 times 5, -30. Then multiply here to get +10. And then add and subtract left to right. That'll be -34 plus 10 is -24. Hope you guys got that correct. If you did, great job. All right, now we're going to go back to solving equations. So solve for the variable. We're going to get m by itself here. Now when we're solving equations, we first, just like we did in one of the warm-up problems, let's get rid of parentheses. Now in the first one, there's nothing to distribute in that m-2. Those parentheses actually can drop. That's a -5 after it, not a -5. So please do not distribute in that first group. So that'll be m-2 minus 5, and then equals. Now here, do not do 8 minus 2 and get 6, and then distribute the 6. Please don't do that. Remember, multiplying, this -2 is actually multiplying. It's trying to distribute here. So in order of operations, you should do multiplication first. So the 8 drops down for now. And then we're going to multiply -2 times m, -2 times -4. Then after that, what we want to do is we would need to combine like terms. On the left side, we have like terms right here. So that'll be m minus 7. When I say combine like terms, that means they're on the same side of the equal sign, and we have to do what it says. Like, what is negative 2 minus 5? It's negative 7. When we're in the combine like terms phase, you do not do the opposite thing there. All right, so what's next is combine like terms on the right side as well. 8 plus 8 will be 16. All right, now what's next? I got variables on both sides. That negative 2m on the right, let's bring that over, that whole term over to the left. So we're going to add it to the like term, the m. So 3m minus 7 equals 16. And now we can finally work on trying to get this m by itself. So we're going to add 7 to both sides. Remember, cancel on the one, you do the math on the other. And then divide by 3. And for your answers, you can either have, if you have a fraction, try to reduce it. 23 divided by does not reduce with 3. You can either get a decimal or you can get a mixed number. Like 3 goes in 21 7 times with a remainder of 2, so it's 7 2/3. If you don't remember how to do this, all right, if you don't remember how to change an improper fraction to a mixed number, definitely pause this and go onto YouTube now and look it up. That's something every single human being should know. All right, letter B. What would we do first here? We want to distribute the 6. Get rid of parentheses. So 6 times x and 6 times negative 4 will be minus 24. Then after that, you can combine like terms on the right side. You got some like terms. No other like terms. We have variables on both sides. Let's bring the 6x over to the left. And then we can finally work on getting x by itself. Subtract 5. And then divide by negative 2. That'll be positive. 2 goes into 2010, and left over 1, so 10.5. Letter C gets a little tricky here. Please don't be intimidated. We're going to get rid of the 5 first because, as I said earlier in the lesson, when you have a coefficient of x, you get rid of that 3/4 last. So let's go ahead and subtract 5 from both sides. Okay, now how to get rid of the 3/4. So I'm going to show you without a calculator. A lot of you would say, oh, I'm going to divide both sides by 3/4. But you can't divide by 3/4 in your head in one step. What you want to do, you can do this in 2 easy steps. The first step you can do is get rid of the fraction. If the denominator is 4, multiply both sides by 4. It cancels here, and you no longer have a fraction. And then 39 times 4, 36, 3 times 4, 12, 156. And then you can easily divide by 3. 15, 5. 52 is your answer. Remember, if you guys ever want to check your answers, you would take your potential answer, go back in the original problem, plug in for the x or x is, and then use order of operations to see if both sides come out to be the same number. Letter D, we are going to distribute first here. Distribute this 3, so multiply it twice. 3 times x, 3 times minus 5. I do note, then we look to combine like terms. We have them right here on the left side of the equal sign. So the negative 15 plus 3 is minus 12. And then, we got a situation here. We have variables on both sides, so I would say, watch what's going to happen. I would say, well, let's move this over. Let's subtract 3 from both sides. Now it would cancel here, and it would actually also cancel here, becoming 0x. And if you have 0x, that's 0, meaning no more x's in this problem. They're gone. So we have a special case here. We're not going to actually have one solution like the other problems. Drop down the numbers that are left over and take a look at them and ask yourself, is that true? Is negative 12 equal to negative 12? Of course it is. So we need to put a phrase here that means what we do is we can write all real numbers. All real numbers, meaning every number in the world, if you took it and put it in for the x's back in the original problem, both sides would come out to be equal after we did order of operations. Another thing you might have seen before, instead of using the phrase all real numbers, you can use infinitely many solutions. So infinitely many solutions is acceptable as well. Okay, you pause this now and try this problem out. Okay, I'm going to fly through this problem, and let's see if you were correct. I'm not going to talk much here. I'm trying to speed it up for time length, so my video is not too long. All right, negative 6. Hopefully you got it correct. If you did, great job. Okay, I'm going to stop here today. I'm going to break this up into 2 parts. So I'll continue with the other part at another time.